So a couple of things I wanted to mention about your test, which I have handed back to you. On your tests, I put the percentage on there just so you could kind of know what you got as a percentage. But when I put it into Moodle, remember I split that chapter in half, so it went in out of 50. So what you have in Moodle is probably half of what your percentage is. Actually, probably a little bit more than half, because I think I added a little bit of cushion points to everybody's score. So that is why they look the way they do. So for instance, if you got an 80% in Moodle, it probably said 40 or maybe 41 or something like that. Okay. If you got a 90%, it probably said like 45 because it was out of 50 in the Moodle assignment because it was half for each of those tests. Right. So together it was 100 points, but each one was half. Okay. The next thing is next week is what? Today is the 13th, right? So next week is the 20th. We have our test, and the test next week is still going to be relatively short because our logarithm unit is just relatively short. So the test next week is over section 4.1, which is what we did last week. And then the two types of equations, the exponentials and the logarithmics. We've done the exponential equations. We're going to do logarithmics now. But that's what our test will be about next week. Now I'm going to give you guys an option here. And I'm going to explain why I'm giving you the option. But next week we're going to have our test, and we're also going to cover section 4.6, which I told you would be a little weird because I was planning to cover 4.6 after the test, and it was still in chapter 4. So here's my question. I'm going to let you guys decide, but you have to decide tonight because otherwise we're not going to decide during the week. Okay. My question is: would you rather cover section 4.6 first before the test? And then take the test, and then, okay, so cover section 4.6, then do some review time for like a half an hour, and then take the test, and then you get to leave when you're done with the test? Or would you rather review, take the test, and then come back and do section 4.6? And here's one more piece to the puzzle. Section 4.6, I am going to have one problem on the test from section 4.6, but it'll be extra credit. Okay, so it won't count against you, but you know, because it's just application. Section 4.6 is just application of what we're already doing right now. Okay, so it's going to be kind of like section 1, but using some equations from section 3 and 4.
I really do.
Which one?
The extra credit, so we do it.
I mean, there will be extra credit. There will be, no matter what. You just won't have specifically seen it if we do that after the test. So that's why I'm asking you what you guys would like to do. And we'll be very democratic about this. Does everybody understand the two options? Okay. Option 1, we cover section 4.6, then we review, then we take our test, and you can leave. Option B, did I say 1? Okay, then option 2, we review, take the test, and then do section 4.6, and then you leave. So who votes for the first option where we do 4.6 before the test, and then we do the test afterwards? Who votes for the test first? Okay, test first. That's why I let you guys vote, because I don't care. Okay, so next week for our schedule, we'll review, like I said, until about 7:30. So from about 7:10 to 7:30. If you want to get here early, as long as the other class is not in here, we will review. If the other class is in here, I think this classroom right next door is like just a study room, right?
Yeah.
So we make, there's probably no board there. If you have a notebook, we'll just go through it there. So if there is a class in here and you guys get here early, I will be here early. I'll try and be here around 6 or 6:15. So if you have questions that you want to ask, you can do that. I think I've got the review set up. I'll probably double check it tomorrow, but I think I've got the review set up for whenever you want to start working on it. Section 4.3 and 4.4 will be due next Monday, just like they normally are. The review will be there, and then we'll take our test, and then we'll cover 4.6. Okay, so that'll be the plan for next week. The following week, we're going to cover the next unit. There's only 2. It's a very short one. There's only 2 sections in it. We'll take our test the week after that, and then we'll talk about the final, and the final is the week after that. And then you guys are done. You guys are like, yes, you can get out of here, right?
If we pass. If we pass.
Oh, if you pass. What do you mean if you pass? We're going to pass, right? Hopefully. All right. Let's see. So I talked about all that stuff. I think we're good to go. Okay. Some more logarithmic properties in section 4.4. And also, we're going to move on to logarithmic equations. So we talked about log properties in section 4.3 with exponential equations and how they helped us solve those. In 4.4, we're going to talk about how we can solve logarithmic equations using some more properties as well. All right, so I guess there's nothing really to write there. There we go. Remember, and this is just review from the last section. I wanted to put this up here just to refresh our memories. We talked about the cancellation properties, right? If the bases are the same, they can cancel out, and what's left is whatever that exponent is or whatever you were taking the log of. Okay? That's the first one we talked about. Then we talked about the exponent property, right? That's the one we were using to help us solve those exponential equations. If you've got the log of any value to the r power, that exponent can come out in the front, and now it's r times log base b of a. Okay, so that's the exponent power that we were using a lot as we were solving those exponential equations. We also talked about the change of base formula, which allows us to evaluate, even though our calculator doesn't have buttons for all these other bases, it allows us to evaluate even if the base is not a 10 or an e. So that's the stuff we talked about in section 4.3. That's just some review. So you've probably already got it written down, I would guess. A new one. This is the sum of logarithms property. We've got two of them, sum and difference. But here's the sum of logarithms property. If you have two logarithms that are added together and they have the same base, what does it look like we do with those? So you have log base b of a plus log base b of c. What do we do with the a and the c? You multiply them together. And again, I mentioned this earlier. Remember how I said that logarithms are exponents, so they follow the rules of exponents? When you have two things with the same base and you multiply them together, and again, this is from a long time ago in the semester, but we add the exponents together. So that's actually going this way. We've got two things that have the same base and they have exponents. We add the two exponents together. Now again, in our class, what we're going to do is we're probably going to be going from this left-hand side to the right-hand side, but you can also go from the right-hand side to the left-hand side. Okay, in some math classes, that's better. We want them broken apart into little pieces. In our class, we're going to want them put together in just one piece. Okay, so that's the one on the left-hand side, we want it broken apart if you're in a calculus class, because it's much easier to work with them, the calculus stuff, if they're all broken up into tiny pieces. For us, with equations, we want them all put together. So we're going to be combining them most of the time. Okay, the other one is the difference one. The difference of logarithms property. Well, notice this time we're subtracting. It's a difference. And what do we do with the a and the c this time? We divide them. Right. So, and again, notice I don't have parentheses there. You don't need the parentheses around the a and the c. You can put them there if you want to. With a calculator, you probably want them there. But when you write them, you don't always have to have that. And again, for our purposes, most of the time we'll be going from this writing over to this one, where we're putting it together as one logarithm. Okay? Everybody have that written down who wants to? Just about? Got it? All right. So what we're going to do is we're going to take, and I'll read this for you. It says write log base 3 of 5 plus log base 3 of 8 minus log base 3 of 2. We're going to write that as a single logarithm. So log base 3 of 5 plus log base 3 of 8 minus log base 3 of 2. Now, one thing that I do want to emphasize again, I'm going to go back just for a second. I'll be right back to this, but in order to use these properties, the bases have to be the same. You can't have one of them be like log base 7 and another log base 2 and use this property. Okay? So notice log base 3, log base 3, log base 3. They're all the same. So that allows us to use the property. Okay? So as we look at doing this, hopefully we notice we've got a plus sign right here. We've got a minus sign right here. Right? And we're just going to work from left to right. What does it mean that we have a plus sign between these two logarithms? Sorry? We're going to multiply. Now, what are we going to multiply? Yeah, and in this case, that's the 5 and the 8, right? Okay, now let's go ahead and do that. What is 5 times 8? 40, correct. So we have log base 3 of 40, and then we still have minus log base 3 of 2. Okay, so does everybody see what we just did? Because those two logarithms were added, we were able to multiply the numbers in there. Now we want to deal with this minus sign. What happens when we subtract logarithms? We divide. So this would say log base 3 of 40 divided by 2. Okay, and you're always dividing by the one that's after the minus sign. And so what do we know that 40 divided by 2 is? 20. So to rewrite this as a single logarithm, we use those properties and we were done it. Okay, that's all we were asked to do, is just rewrite it using those properties. Okay, any questions on that? Does that make sense? Okay, so log base 3 of 20 is our answer. Let's do another one. Now this one says, a little bit different question. This one says evaluate 2 times log of 5 plus log of 4 without using a calculator by first rewriting it as a single logarithm. So 2 times log of 5 plus log of 4. Now, hopefully we all see the plus sign here, right? But in your order of operations, what comes before addition? A couple things, but do we see that the 2 is multiplied by this log? We did that in the last section, right? What happens when you have a number multiplied by a logarithm? What do we do with that number? Yeah, and usually we brought it down, right? But the same property allows us to put it back up. So what we're going to do is this 2 goes up and becomes the exponent of the 5. So this will be log of 5 squared plus log of 4. Now, again, let's simplify. What is 5 squared? 25. So we've got log of 25 plus log of 4. Okay, now we're ready for the plus sign. What does the plus sign tell us that we should do? Multiply. Right, that was the sum property. So we're going to have log of 25 times 4. And what is 25 times 4? 100. Now, they told us to evaluate it without using a calculator, right? How can we do this? Well, if you remember, we actually did this previously. We said, okay, well, we want to know what the value is. We'll see how much you guys remember in an hour or so. You remember what we did? We rewrote it from logarithmic form into exponential form. So how would we rewrite this from logarithmic form into exponential? Remember the first thing we always identify? The base. What is the base? 10. So 10 to what power? To the v power equals 100. So we have to think 10 to what power equals 100? What is it?
3.
Not
Wait.
3. That was the one we did last time, right? You're just remembering it.
1. Or
2.
2.
2, right? Because we did 1,000 last time, so we had 3. Trying to use your memory, just memorize the answers. No, it's 10 squared, right?
Yeah.
So our answer, our value of this whole thing is 2. Once we simplify it, we find out that that is 2. Now again, in real life, if you had your calculator, you could just type this in because we have a button on our calculator that does log base 10. So there'd not really be any reason to do it this way. There wouldn't really be any reason to do it this way, other than I'm specifically asking us to do it so that we can practice the properties. Okay? And so that is that one. Here it is, hiding behind my computer. Okay, so we get 2 for our answer there. Does that make sense, the steps we went through? So now we have 3 properties. We've got the exponent property, which means we can move that exponent back and forth in front of the log or back up to the exponent if we need to, one way or the other. We've got the sum of logarithms property and the difference of logarithms property. Those are the 3 that we kind of use a lot to try and simplify these. Okay, now like I said, you're not going to be doing a lot of this in this class, but we're going to practice it at least once. And we're going to rewrite this rewrite it as the sum or difference of logarithms. So in other words, we're going to take this one logarithm and break it apart into its little pieces. So just the opposite of what we just did. Okay? So I'm going to help us through this one because I've done these a lot and you guys haven't. But does anybody have an idea of what you would try first? Yeah, what I would say is think about the main thing that's happening here, and the main thing is you've got this top part divided by the bottom part. Right? And when we divide those things, we can rewrite it as subtraction. So the first thing we would want to do is we can rewrite it as natural log of x to the 4th y minus natural log of 7. Does that make sense? We're just doing the opposite direction of our difference of logarithms property. Okay? Now, the next thing that you hopefully see is, now the natural log of 7, we're pretty much done with that, right? There's nothing else you can do with it. But here, we have x to the 4th times y. Well, how can we break that up if it's multiplication? Yeah, we break it up into addition. So we're going to have natural log of x to the 4th plus natural log of y minus natural log of 7. And like I mentioned, natural log of 7, that's done. It's just 7, right? And now natural log of y is just done. Does that make sense? There's one more thing that we can do here with this first piece. The 4, that's right. We're going to use our exponent rule. The 4 comes out in the front. So to finish this all up, we were already done with those. We're going to have 4 times natural log of x, and then plus natural log of y, and then minus natural log of 7. Okay? And like I said, in this class, we're not going to do that a whole lot other than just to practice the properties. But if you would ever go on and take a calculus class and you have stuff like this, you want it broken up like this because it's really, really easy to do the things that we do in calculus when it's all broken up into tiny little pieces like this. Okay, the smaller the pieces, usually the better it is in calculus. So, okay, I got people shaking their heads and giving me dirty looks like, calculus, why would you even say that word in here? Anyway, that's okay. I understand. Okay, does that make sense? That example? And yeah, the parentheses or no parentheses, it doesn't matter. They're automatically around the X and around the Y and around the center. Okay? Are we good with that one? Okay. It's time. Not to go home. It's time to do logarithmic equations. Okay? And really with logarithmic equations, we just have one main step. I should have put one step in front of this probably. We still have the first step. We want to isolate the logarithm part. So let me add that in here so we don't forget it. Isolate the logarithm. Here, I'll put another one here too. Rewrite it. Rewrite the logarithmic equation in exponential form, and then solve using algebra. I guess I just put the main step there, but we still have like 3 steps. So remember we had 4 steps for exponentials. We've got 3 steps for logarithmic equations. Okay, and again, that's the 2 big things in this unit: solving exponential equations, solving logarithmic equations. That's the main 2 concepts from this chapter. I mean, we could have done a lot of stuff. We could have looked at the graphs. We could have done a lot of different things like that. What we're focusing on is how do we solve these equations? Okay, everybody got it? All right. Let's do this first one. Solve the logarithmic equation. Log of 2x minus 6 equals 3. Now, one thing I want you to notice. So I'll repeat it. Log of, and then parentheses, 2x minus 6 equals 3. One thing I want us to notice is when we think about isolating, you always have the log of something. So that whole thing is the log part, right? It's actually already isolated. Sometimes people get crazy and they see parentheses. We're like, well, let's divide by log or divide by 2x minus 6. You can't. They're stuck together. Okay? That's why we have to get them unstuck, because the x is inside there and it's trapped. We have to get it out of there. Okay, so it's already isolated. So our main step, rewrite it. Now again, this takes us back to 4.3. When we rewrite an equation like this, what do we always identify? Remember, this is the identify the base first. What is the base in this one? The base is 10. The base is, remember, there's nothing written here, right? Nothing written there. So the base is automatically 10. 10 to what power? The third power, right? Remember the other 2 switch spots? So 10 to the third power equals the 2x minus 6. Okay? Does that make sense? We did that in the beginning of 4.3. We're going to do it several more times right now, because this is how we do these. Okay? And once it's written like this, well, what is 10 cubed? It's 1,000. And once it's written like this, do you see how we can just use basic algebra to solve this? What would we, yeah, somebody said it, we have to add 6. That cancels this. We add 6 over here too. So 1,006 equals 2 times x. And what else would we do? Divide it by 2. So x equals 503, I think. If somebody wants to double check that for me, but I think it's 503. Let's check. Good. 503 is our answer. Okay. And again, what that means is if you put the 503 into the equation and you typed it into your calculator, because base 10 we can do that, you should get 3 as the answer. Okay. So our solution there is 503. Are we okay with that first example? All right. Let's try another one. Okay, now this gets a little bit more complicated because What do you see here?
2 logs.
2 logs. Fortunately, we learned a secret. We learned how to put those 2 logs together as 1, right? Because they're subtracted. How can we put those 2 logs together as 1 if they're subtracted?
We divide.
We divide. So it's going to be log of 5x plus, no, sorry, I copied that down wrong. 50x plus 25. I'm wondering if I typed this wrong, but anyway, that's what it says. Over x equals 2. So we just put the left-hand side together. Those 2 logarithms go together as 1. Okay? Does that make sense? Using the difference property of logarithms. Now, that logarithm is isolated, right? The whole left side is just a logarithm, and the right-hand side is the other stuff. What do we do next?
Find the base.
We rewrite it. So we're going to find the base. What is the base this time? 10, because again, there's no number here. To what power?
2.
2 equals, and then we just write all this stuff down. 50x plus 25 over x. Now, what is 10 squared? 100. All right, so this is a little bit different than most of the things that we've seen so far. What makes this kind of different? There's an x in the denominator, right? It can't cancel out because of the fact that you got 50x plus 25. So here's what we do. How do we normally get rid of things that are in the denominator that we don't want to be there? We multiply, right? So what we can do is multiply both sides of this equation by x. What happens on the right-hand side when we do that? It cancels. That's why we're doing it, right? So this cancels with this. And technically they become 1s, but when you multiply by 1 and divide by 1, nothing happens, right? The left-hand side, we now have 100x, and the right-hand side is now 50x plus 25. So now we're back to a basic equation, but we do have x's on both sides of the equation, right? We don't want x's on both sides. We want to cancel out one of those x's. Which one would make the most sense to cancel out, do you think? The 50, because that way the x's are kind of by themselves over on the left, right? So how do we cancel out this 50x? Not divide.
Subtract.
Because it's 50x plus the 25, we're going to need to subtract this. Now, after we subtract it, 50x minus 50x is 0, so that cancels out. Still have the 25 over on the right. 100x minus 50x is subtracting.
50x.
So 50x. And then what's our last step to get that x by itself? Divide by 50. To cancel that. And what is 25 divided by 50?
2.
Ooh, people's favorite answer, 2, but that's not right. It's 1/2, right? 1 over 2? Because we just do it's easier, right? Oh, it's easier to divide 50 by 25, but it's actually 25 divided by 50. Okay, does that make sense? X equals 1/2? Okay, let's see if I actually did copy it right. Okay, good, it is 1/2. All right? So if we have multiple logarithms, we want to put them together, either using our sum of logarithms property or our difference of logarithms property. Does that make sense? So if you ever have more than one, see if you can put them together with one of those two properties. You should be able to. Oh, we got 3 of them. All right, let's see what we can do here. Now, there's a couple different ways to do this. We'll see. I might show you both ways or I might not. We'll see. What would you guys do with knowing what we have done so far? Because we've got 3 logarithms, right? What would you try to do? combine which ones?
The first.
The ones on the left, right? And these are added. So what does that tell us that we should do? Multiply them together. So this is going to be natural log of, and I'm going to use brackets because these have parentheses already in them. So natural log of x plus 2 times x plus 1. And that would combine the left-hand side, and that's equal to natural log of 4x plus 14. So I'll pause there for a second because I realize some people are still probably trying to see that. So natural log of, we put them together, so natural log of x plus 2 times x plus 1 equals natural log of 4x plus 14. Are we caught up? Okay. Now, we do have to multiply them, right? We can't just stick them next to each other and say that they're multiplied. So if we multiply these, what do we have to do? Yeah, we've got to FOIL or distribute or whatever word you want to use for it. We always used to call it foiling, but that's kind of going away now. FOIL is an acronym for first, outer, inner, last. It just tells you to distribute. So x times x is x squared. X times 1 is 1x. 2 times x is 2x. And 2 times 1 is 2. This side, we're not doing anything with it right now. We're just leaving it alone. And then we just want to combine like terms. Natural log of, this will be x squared plus 3x plus 2. And then this is still natural log of 4x plus 14. Okay, is everybody with us so far?
How did we go from
Oh,
1x?
these two?
Yes.
So just 1x plus 2x giving us 3x. We just combine the like terms.
Okay.
It's like, I mean, if you think of x as, it's like 1 apple plus 2 apples, you have 3 apples. I mean, obviously x is not apples, but it works the same way. Does that make more sense?
Yes, I thought maybe you factored for some reason.
Oh, no, we just added them together. Okay, so is everybody with us now? Okay, now here is a little property that we've talked about in the past with exponents, but it works for logarithms too. Remember we used this word one-to-one functions? For every input, there's only one output. We talked about that several weeks ago. You don't really even necessarily need to remember that, but logarithms are one-to-one functions. So what that means is, if you have the natural log of something over here, and it's equal to the natural log of this over here, the only way that's true is if this is equal to this. So what that allows us to do is if you have natural log over here and natural log over here, and that's all that you have, you get to cancel them off. So now we just have x squared plus 3x plus 2 equals 4x plus 14. Okay, now that only works if you have just the natural log on the left and just the natural log on the right. That's the only way that works. So don't just randomly start taking off the natural logs all the time. It only works in that one case. One natural log equal to another natural log. Okay, so now we've got an equation, but we have x's on both sides. And what type of an equation is this? And you said the magic word before. We are going to have to factor it. Sorry. It is a quadratic. And when we have a quadratic equation, if you remember the way we solved it, we always moved everything over to one side, either everything over to the right side or everything over to the left side. In this case, it's going to be nicer for us if we leave the x squared positive. So let's leave this here. And we're going to cancel this out. So how do we cancel out the 4x? You subtract 4x. And that cancels that one out, right? So that'll give us minus x or minus 1x. And how do we cancel out the 14? Subtract the 14. And we have to do the same thing to both sides. That gives us minus 12. Okay? And if whether we're going to factor or whether we're going to use the quadratic formula, You always have to get it set equal to 0. So now we've got that. And this one does factor, so let's go ahead and practice our factoring. We don't want to just completely forget about factoring. It doesn't really go away. You could use the quadratic formula and it would work. It just tends to take a little bit longer. So do you remember how we factor? We take this number, which is 1, a times c. That's very good. A times c, which in our case is 1 times -12, and that is -12. Now, since this is a negative, what do we know about the signs of the numbers that we're looking for? They're different signs. One's positive, one's negative. Once we know that, we can look at this and we say, oh, well, they are going to add up to be a negative number. The bigger one is negative. Correct. See, you guys remember some of your factoring, at least some pieces of it. So we want to find factors of -12 that will add up to be -1, right? Because there's automatically a 1 there. Yeah, you already got it. But just in case you didn't know what it was, you could already start listing it, right? 1 times -12 doesn't equal -1. Or it equals 12, but it doesn't add up to be -1. 2 and -6 multiplies to be -12, but doesn't add up to be -1. 3 times -4 multiplies to be -12. Aha, we have a winner. It also adds up to be -1. So this is what we're going to use. And you remember what we have to do after we find those numbers? X squared plus 3x minus 4x minus 12 equals 0, because these two together take the place of the -1x. Right? If we added them together, you would still get -1x. Now we want to factor by grouping. And what can we factor out of the first group? An x. What's left? X plus 3. Remember, we have to factor out the negative. What else can we factor out of the second group? A -4. And what's left? Now remember, you're dividing by a -4. It'll be x plus 3 again. And as long as we did our job right over there, these should be the same. So x plus 3, we can factor that out from both of those. What's left? X minus 4. Okay? Now we're not quite done. What do we get when we solve this? Remember how we solve it? We set it equal to 0?
-3.
Yeah, we get x equals -3 and x equals 4. There's one thing that we have not talked about yet. And it has to do with what you can take the log of. Remember I said logarithms are one-to-one functions? But they do have a limitation. You cannot take the log of a negative number. It's impossible. It doesn't exist. Well, not with real numbers. You also cannot take the log of 0. If you try it on your calculator, you will get some sort of error message because you cannot do it. Okay? So with logarithmic equations, we've got to take these two and go back and check them in the original. Okay? So if we take this 4 and we plug it back in, notice what we'll have here, 4 plus 2. Is it okay to take the logarithm of 6? And the answer is yes, because 6 is positive. We go to the next one, 4 plus 1. Is it okay to take the logarithm of 5? Yes, because 5 is positive. We go check this other one. 4 times 4 plus 14. Well, that happens to be 30. Is it okay to take the logarithm of 30? Yes. So 4, we're pretty confident. 4 is good, right? Then we check the -3. -3 plus 2 is -1. Is it okay for us to take the logarithm of natural log of -1?
No.
No. So what that means is, even though we did all of our algebra correctly and we did all this work and we got -3, we have to cross it off. It doesn't work. Only the 4 works. Because what happens with the -3 is, and it only if it doesn't work on any of them. Now, actually, with this one, it doesn't work here. It doesn't work here, but it does work here. The whole thing is, if it doesn't work on any of them, we have to cross it off. even if there were 7 of them and it didn't work on one and it worked on the other 6, you still have to cross it off. Okay? So that is the one extra little piece. We've got to check our answer. Just to be careful, we've got to check our answer to make sure we don't have an extra answer that doesn't actually work. Okay? So that one did have factoring involved. Sometimes you get easy ones. The 2 to logs just go away and you get an answer right away. But, okay? Any questions on that one before we go on? Notice only x equals 4 is the solution. Okay, algebraically we got 2, but when you check it, the -3 won't work. Okay? Any questions there? Do we understand how we put them together with the sum of 2, put them together with multiplication? Or the difference of 2, we put them together with division, like we did in the last 2 examples? Okay? And that's it. Okay? Now again, we've got, let me erase this so we can see. We've got 9 problems on there, but again, there will be a few that are equations, and then most of them are going to be just using those properties, the sum property, the difference property,